When students work with fractions, they sometimes think about a fraction as two whole numbers, rather than as a number in and of itself. The number line is a powerful tool for building this essential understanding of fractions and other rational numbers. The What Works Clearinghouse Practice Guide on assisting students struggling with mathematics strongly recommends the use of number lines to support student learning of grade-level content and to build a foundation for more advanced mathematics. One great thing about the number line is that it lets us represent a fraction in two different ways. This point on the number line represents the number 3/4, and its value is based on its distance from 0. On this number line, there is only one point that can have the value 3/4. But we can show a length of 3/4 in different locations on the number line. So here's a length of 3/4, and here is also a length of 3/4, and here's a length of 3/4. Knowing that a fraction can be represented as a point or as a distance can help us model addition on the number line. For an example, let's look at an addition problem with unlike denominators. 1/2 plus 3/8. And just at a glance, do you think that the sum will be less than 1 or greater than 1? Okay, let's keep that estimate in mind as we represent the problem. Now, some students find number lines to be confusing at first. So it's helpful to start by connecting a concrete representation, in this case we'll use fraction tiles, to the semi-concrete number line. So here's a number line that extends from 0 to beyond 1. The distance from 0 to 1 is the same length as the fraction tile for one whole. To solve the problem, I can use the fraction tiles to help me find the location of the first addend, 1/2. So I'll place a 1/2 fraction tile so that the edge is exactly at 0. And I'll label the location of 1/2 on the number line. Next, I'll use the fraction tiles to add 3/8 to 1/2. The total length of the tiles is now the sum of the fractions. And I can see from the representation that the sum of 1/2 and 3/8 is less than 1. Okay, but how do I write this sum as a fraction? Because right now I've combined two fractions with different denominators. Let's see if we can use the 1/8 fraction tiles to make the same length as 1/2. So we put out 1, 2, now we have 3 of them out there. Okay, and 4 matches exactly. So we can see here that 4/8 is equivalent to 1/2 because they're the same length. So I'll trade the 1/2 tile for 4 1/8 tiles. Now I can mark the number line with eighths. And I see that my sum is 7/8. Now let's look at how we can represent this same problem on a number line without using fraction tiles. First, I'll need to partition the number line into eighths, because eighths is a common denominator for halves and eighths. To get 8 equal parts, it's difficult to just start at 0 and draw tick marks that are equally spaced. So instead, I'll systematically partition the number line, first into halves, then fourths, then eighths. And I'll label my 8 equal parts as eighths. Now that the number line shows eighths, I'll draw a point to show the location of the first addend, 1/2, which is the same location as 4/8. And I'll model adding 3/8 by drawing an arrow that starts at 4/8 and is the length of 3/8. Now I can see that the location where the arrow ends is my sum, 7/8. Okay, let's recap how we use the recommended strategies from the What Works Clearinghouse Practice Guide. Because number lines can sometimes be confusing, we started by using the fraction tiles to model how fractions are represented and combined on the number line. Then we used a different approach. We drew points and arrows on the number line to visually show the addends and the sum. By using these two approaches to add fractions on number lines, students build their understanding of the underlying concepts of the operation. We encourage you to try these approaches to engage your students in using number lines to model and solve problems.